Hi everyone, I want to show you the features that are now available in our October release of the D3A by Grid Singularity. We've released 6 features in October, and I'm going to take the time in this video to explain them to you. So the first feature is that you can now run a simulation for 1 week. So to do that, just go to your global settings page for a simulation, and then we have the start date for the simulation and the end date. So simply just move the end date to 1 week after the start date. And from there, you can click Next and then run the simulation. So while this is running, I'll go back and show you the second feature, which is that you can choose your market type. So previously we had the one-sided pay-as-offer market for our spot market type, and now there are 2 other spot market types here. So simply just choose two-sided pay-as-bid or two-sided pay-as-clear, and then you can run the simulation for that market type. In addition, you can also change the number of spot markets, the length of the spot market, which may affect some of your devices, and the tick length. But these are more advanced settings, so we'd advise reading the wiki before getting into those. So the third feature is related to the results page. So this we ran this simulation for 1 week, and viewing the results page, you can see that all the data for 1 week is printed on the graphs. And so the third feature is that we've made these graphs scrollable. So you can see the data printed for 1 week, and then you can also make the size of the x-axis smaller or bigger, so you can zoom in on the data and look at the data for 1 or 2 days in one viewer frame. And so we applied this to all of our graphs. So going to the energy profile graph, we have a whole week's data here, but we can also zoom into 2 days or even to part of 1 day to look in particular at a specific data point. And this also applies to the devices. So for the PV, for example, shows the results for an entire week, and we can scroll in to see the details of the data for a couple particular days. The third feature is that you can download your results. So on the results page, you simply click Download Results, and the results will be downloaded as a zip file. This is actually the fourth feature. So opening the zip file, you'll see a history of all the trades for all the markets. So it's broken into the hierarchical structure of your grid. So we had the area, and then inside the area market, there's the area 2 market, which also has the smaller markets, smaller areas, my neighbors and my home. So all of the trades are listed here as CSV files. And in addition, in the aggregated results, there's the bills JSON file, for example. And so this lists the energy bills of all of the areas and devices. And so this data is the same data that we're showing on the results page. For example, here we're pulling directly from our energy bills file, for example. So those results from download results are the same results that you would get when you run the simulation using our backend user interface. So moving on to the fifth feature. The fifth feature is to configure your market maker. So let's go back to the home page and make a new simulation. I'll call this My Community 4. And you used to configure the market maker in this global settings page, but now we have added the market maker as a device in the grid configuration page, in this page. So, and the purpose of this is so that it's easier for the user to understand what their market maker is and the purpose that it serves in the simulation. So we'd start adding an area, and then as the second step, we're forced to add the market maker. So the market maker is here, and a market maker basically represents a utility or a device like a diesel generator that can supply energy to a community, and the price of the energy from the utility or from a diesel generator is the price of electricity, and this is the base price that influences the prices of the devices in the simulation. So the devices buying and selling energy in a community, for example, wouldn't place offers higher than the market maker rate, because then those loads could actually buy from the market maker. So here we just have the market maker has two roles. So it acts as an infinite power plant when it's grid connected. So we've actually deleted the infinite power plant from our devices and have combined it with the market maker here, because that's how it behaves in a grid connected situation. And then the second option is that the market maker acts as a price setter in an islanded microgrid. And so that's the case where the market maker is not actively selling energy to the grid because it's islanded, but it's providing some kind of price basis for the devices in the grid. For example, it's representing the cost of a diesel generator. So as a user, you can input the market maker rate, which would be your utility rate tariff, for example. You can also upload a file in case you want to upload a time of use rate or other type of rate tariff from the utility. So we'll keep this at 30 cents. And then you would start to configure your community. So we would add an area here, and then we would add, this would be home 1, for example, and then home 2. And then going back to the market maker, then we could see, okay, maybe this is an islanded microgrid. So we would click here and the market maker becomes disconnected from the grid. So in this case, the devices inside home 1 and home 2 would trade with each other, and they wouldn't actually be able to buy power from the market maker, but they wouldn't be selling their power at rates higher than what the market maker is offering. In addition, with the market maker, you can also save it to the library. And you can just add it here. And then if you want to input more grids to your simulation, you can go to the library and also import a different market maker. I'll just reconnect this for this example. So that's our 5th feature. The 6th feature and the last feature has to do with the device strategies. So I'll go ahead and add one of each of the 3 devices that have the strategy here. So add the load to home 1 and the PV. And then in home 2, we'll add the storage. And for this example, let's look at the two-sided market. So I'll change my market type to two-sided. And the way that the device strategies work in the two-sided market, everything here stays the same. And in the two-sided market, for a load, you would have an initial buying rate and a final buying rate. So the load is putting bids into the market, and its bid would start at a low number and would work up to the highest rate that is willing to buy for. So in a one-sided market, the load wouldn't have an initial buying rate because it's just a price taker, and it's buying energy at the price that's offered to it. So really in the two-sided market is where we see the load behaving similar to a PV, for example, with an initial and a final buying rate. So the user can set these values, and the final buying rate is tied to the market maker because the load wouldn't buy for a price higher than what the market maker is offering. And then we have the rate increase. So the default is a 15-minute market slot. So within a 15-minute market slot, the load can increase its bid from 0 to 30 cents per kilowatt hour. And here the update interval is 5 minutes. So that means every 5 minutes, the bid can increase its buying rate. So we can set the rate increase to 15 cents per kilowatt hour per update. So that means within a 15-minute market slot, the load will first try to buy at 0 cents. Then after 5 minutes, it will try to buy at 15 cents. And then for the last 5 minutes, it will try to buy at 30 cents. And so this way, the load increases its bid and can go from its lowest bid price to the highest. So the user can change this update interval, but we recommend keeping it on 5 minutes. The user can also change the rate increase. So if you change it to 2 cents per kilowatt hour per update, then the price would go from 0 cents to 2 cents and then to 4 cents. So within the market slot, it would never actually reach the highest final buying rate. So this is something that maybe you'd want to experiment with if you're looking at introducing competition between different devices and you want one device to decrease or increase its buying or selling rate faster than another device. But mostly we recommend clicking fit to limits, and the fit to limits just guarantees that the rate increase is a number that guarantees that it will go from the initial to the final rate. So it guarantees that the bid would start at 0 and then end at 30 cents and manages to cover the entire range. So the PV is very similar. It's just slightly the opposite because it has, and the initial selling rate is the market maker rate, and then the final selling rate is 0. And of course, the user can input whatever final selling rate they want here. The rate decrease tells you how many cents the rate is decreasing during the market slot. And so the update interval and the fit to limits works the same. When the fit to limits is checked, then the rate is guaranteed to go from the market maker rate to the final selling rate. So here, if I put the final selling rate at 15 cents, for example, then the rate decrease is adjusted accordingly to 7.5 cents to guarantee that the market maker rate can decrease from 30 to 15 cents throughout the entire market slot. And the storage works in the same way. It's a little bit more complicated because the storage is buying and also selling. So the storage is putting bids into the market at the same time that it's putting offers. So across the price spectrum of 30 cents per kilowatt hour to 0, we have the default for the storage is that it will try to sell energy between 25.1 cents and 30 cents, and then it will try to buy energy between 0 cents and 25 cents. So these are the default values, and they can be changed by the user. And so these work the same, where there's the rate decrease and the rate increase for the selling and the buying, and this can be set to cover the full spectrum from the initial to final number based on checking the fit to limits. So in this case, the rate increase is calculated for the buying rate to go from 0 to 25, and the rate decrease is calculated for the selling rate going from 30 to 25.1. And of course, the user can type in their own values. So I hope this makes sense, how I went over the device strategies. If you have any more questions, please reach out to us. We could possibly do a video getting into more detail there. And we've put some more information on our wiki about how this can all be configured. Thanks a lot for watching, and stay tuned for the next update in our November release. Thanks.